Assalamu alaikum students. This is Dr. Munir Omar with CS222 Database Management Systems. Today in lecture number 45 we will study about the fourth normal form, the fifth normal form and the domain key normal form. So far we have studied the normalization topic up to the Boyce code normal form that is also known as BCNF. So this lecture would be the last lecture to cover the normalization topic. So these are the contents for our today's lecture. First, we will look into our previous lectures. This would be a short summary of the previous lectures. Here we will see the definitions or the procedures for the normal forms, and after that we will start our lecture with the fourth normal form. Then we will have some examples and we will decompose some tables to make those tables in fourth number form. Then fifth number form will be discussed, and also we will decompose some tables for fifth number form, and at the end domain key number form will be discussed. So first we are looking into our previous lectures. In previous lectures we studied about the normalization and then the normal forms up to BCNF. So as you know that normalization is a process for decomposing different tables to reduce the redundancy in database. So actually these tables may have some redundant data in them, so that redundancy may cause anomalies. We have already studied three types of anomalies. So to avoid anomalies we reduce redundancy, and for redundancy we decompose different tables to construct new smaller tables, and this process is known as normalization. In the process of normalization, we look into different type of dependencies among the database table attributes. Then we studied about the first normal form. In first normal form, we look into the database table entries. If there are multi-value attributes, so we eliminate such type of attributes. We remove the repeating groups. We make all the attributes to have atomic values, and we also determine the keys in the table. In second number form, we look into partial dependencies. If there is a composite key and some attributes are dependent on part of that composite key, then there would be some sort of hidden dependency among these attributes. That hidden dependency is called partial dependency. So we must remove such type of dependencies in database tables. So for this purpose, we decompose the database tables and create some new smaller tables, and also specify the primary key and foreign key to connect the new created tables. Then in third normal form, we look into the transitive dependencies. If A is determining B and B is determining C, then it is obvious that A will also determine C. So if we have such type of attributes in a single table, then we must split that table into different segments to remove transitive dependencies. Example for transitive dependency is student is determining program, program is determining credit hours. So if these three attributes are present in a single table, then we must split that table into two different tables to remove this transitive dependency. In BCNF, we look into the candidate keys. So we say that all the candidate keys must be determinant. So for this purpose, we split tables to make all the candidate keys as determinants. Now we are starting with our today's main topic, that is fourth normal form. After fourth normal form, we will look into fifth normal form and then domain key normal form. So the fourth normal form eliminates independent many to one relationships between columns. It is possible that many columns associate to a single column, so we must eliminate such type of relationship in the database tables. So once we eliminate such type of dependency, then the table would become in fourth normal form. To be in fourth normal form, the relation must be in BCNF. This is obvious. Once the table is in BCNF, after that we would be able to convert it into fourth normal form or apply some rules and decompose it for fourth normal form. A given relation may not contain more than one multi-value attributes. Now we will look into these two things in the coming examples. So here we have an example. We have a table. It has three attributes: movie name, screening city, and genre. So in this table, all these three attributes are combined and all these are considered to be a single key. All columns are part of only candidate key, hence BCNF. There is no key that is not determinant, so we have only one candidate key in this table, so it is in fourth normal form. Actually, we must make a composite key of all these, otherwise we will violate the primary key rules. Then many movies can have same genre. So here we have many, here we have one. So many to one relationship among the attributes. Many cities can have the same movie. Again, many to one relationship. Now if you look into this table, so here we have some cities for movies. Now if you look into the screening city, Los Angeles and New York both have same movie, means that there is many to one relationship. Same is the case for second movie. Here we have many and here we have one. This could be also a case where we will have some movies here and have same genre, like we may have two or more movies, and that would be in the comedy type. So it is also possible, and this case would be also many to one relationship. We have a second example. This one is also not in fourth normal form. Here we have three attributes: manager, child, and employee. The primary key is composite of all these three attributes, and we can say that this is a candidate key and it is determinant because there is no other attributes. So definitely it would be in BCNF, Bice code normal form. Each manager can have more than one child, it is obvious. So we can say that one manager can have many children, so many to one relationship exists. One manager can supervise more than one employees, so one manager and here multiple employees, so this is again many to one relationship. Here this would be the sample entries for this table. Here this manager Jim can supervise many employees here, and this manager can have many children. So in both cases, we have many to one, again many to one relationships in these attributes. So this is not in fourth normal form. Then we have third example. Here we have three attributes: imply, skill, and foreign language. The primary key is composite of all these three attributes. So this is a candidate key and it would be in BCNF as per the requirement for BCNF. This is a candidate key and it is determinant because there is no other attribute. Each employee can speak multiple languages, many to one relationship. Each employee can have multiple skills, so many to one relationship again. Here we have one employee, and this employee can do many things here and can speak many languages. So we have many to one, again many to one relationship among these attributes. Now we need to compose these tables in our examples. First one was about movie, second one was about manager, child, and employee, third one is about employee skill and foreign language. So we need to decompose these tables. So what will we do? Move the two multi-valued relations to separate tables. We are actually going to eliminate the many to one relationship. So for that purpose, we must create some additional tables or decompose the existing table into multiple tables. Identify a primary key for each new entity. Once a new table is created, then we must also identify the new primary key for that table. So the old scheme had three attributes, and all these three were combined to make a composite candidate key. Now we created two new tables from this old table, and in these new two tables we actually splitted the attributes so that we may delete the many to one relationship. Now here we have movie and genre in one table, and movie and screening city in other table. So this way we can convert a table into fourth normal form. For second example, we had three attributes combined together to make a candidate key. Now if we split this table into two tables, then it would be manager and child, then manager and employee. So in this way we will eliminate the issues that are required for fourth normal form. Here in third example, we are decomposing the table having three attributes and making two new tables, splitting the attributes and making some new dependencies. So in this table we will have employee as the primary key, and here this employee would be primary key, and these both will be connected so we can get the exact data as we were getting from the previous table. Fifth normal form. Fifth normal form applies to M-way relationships. In fifth normal form, all tables are broken into as many tables as possible in order to avoid redundancy. Actually, the fifth normal form is the last step for decomposition, and in this normal form, we decompose all the tables up to their maximum possible level. Once it is in fifth normal form, it cannot be broken into smaller relations without changing the facts or the meaning. So the fifth normal form is the last stage of decomposition. Once it is in the fifth normal form, after that we would not be able to further decompose the tables. If we intend to decompose the table, then we may lose some data, or we will need the change in the schema. We will need to have some additional things or elimination of some facts in the data tables. This is the example for fifth normal form. A relation is in fifth normal form if it is in fourth normal form. This is the first condition, and won't have lossless decomposition into smaller tables. We will decompose this table until we get a smaller, we will get a set of smaller tables that don't lose any data during the decomposition. So we can also consider that a relation is in fifth normal form if the candidate key implies every joint dependency in it. So this table can be decomposed into three new tables. So this is the last stage of decomposition. We cannot further decompose these tables. Then we have another example. In this example, we have three attributes, and these three attributes or this single table can be further decomposed. Relation is in fifth normal form if it is in fourth normal form, already discussed, and not contain any joint dependency, or joining should be lossless. Now here, if we look into this table, there might be some joint dependency. For example, this David and semester, they are dependent on, let's say, computer. So there is joint dependency. So if we break this table into multiple tables, then this dependency will be lost, or this will be eliminated from this record. Fifth normal form is satisfied when all tables are broken into as many tables as possible in order to avoid redundancy. This is the end of decomposition. So we decompose the tables up to their maximum possible. Fifth normal form is also known as project join normal form, BCNF. Actually, fifth normal form is not that much common. Usually we normalize our databases up to third normal form or BCNF. This normal form is not in general practice because it makes the database very complex. So this table is decomposed. Here we made this semester as primary key, subject for primary key, and again semester as primary key, and all these are connected. Next we have domain key normal form. Domain key normal form, or DKNF, is a bit different than other normal forms. In this normal form, we actually focus on the domain of an attribute, or the possible set of values for an attribute. So a relation is in DKNF if all the constraints and dependencies on the relation can be enforced by enforcing the domain constraints and key constraints on the relation. In DKNF, we look into the constraints and dependencies on a relationship. On a relation. So the main thing is to enforce the quality of data, or the set of possible values and other constraints on the database tables. A domain is the set of permissible values for an attribute. We have already studied this topic, the domain of an attribute. So actually, by domain of an attribute, we mean that the set of possible values for an attribute. Now let's say we have salary as an attribute. So the possible values for salary would be numbers or positive numbers. So for age, we will have also the uh, numbers in the values, and if we have any attribute for date of birth, then the possible set of values would be date. The type of that attribute, the data type of that attribute would be date. By enforcing key and domain restrictions, the database is assured of being freed from modification, insertion, and deletion anomalies. Actually, once we enforce these constraints and dependencies, then we can say that this database is freed from insertion and deletion anomalies. Designed to specify ultimate normal form, though this is not the exact normal form as we studied, it is a bit different, but we can say that this is the ultimate normal form which uses all possible type of dependencies and constraints. DKNF is the normalization level that most designers aim to achieve. Actually, when we design a database or database table, we specify the domain of attributes, and we also put some constraints on that database table, and most of the constraints come from the DBMS automatically. So once we achieve all these, then it would be considered at the peak of construction of database or design of database. So this is desired by most of the designers. The practical utility of DKNF is limited because it is difficult to specify general integrity constraint. In most of the cases, we cannot specify the exact or the ultimate domains of attributes. So this is a bit difficult for us to apply DKNF at the peak, and we cannot specify the ultimate constraints on a table. It has been shown that a relation in DKNF is in fifth normal form, and that DKNF is not always achievable. Here we have an example. For example, we have an entity or table named as car. It has some attributes: make and VIN number, manufacturer. This is another table. It has two attributes. The country is actually the manufacturing country of this car. A complex constraint is for Toyota or Lexus made in Japan. The first character of VIN, the vehicle identification number, is J, and for a Honda or Acura made in Japan, the second character of VIN is J. So this is a kind of constraint or restriction that when we give the vehicle identification number to Toyota that is made in Japan, then the first character and VIN should be J. And if the vehicle is Honda or Acura made in Japan, then the second character in VIN should be J. It is similar to our registration numbers. Now, if you know that we type CS, this is for computer science, in the student registration number, then we type one digit. This one digit is used to identify something. It would be the type of program, whether it is BCS or MCS, MS, etc. Then we type some other digits that could be used to specify the date of admission, and after that we specify some numbers to identify the number of that student or the serial number of that student. So this also comes under the DKNF. Then we have another example which is about bank. We have branch, then account number and balance. This is a table identified by R relation. Constraint, what do we need? An account number beginning with 9 is a special account which requires a minimum balance of 2,500 US dollars. So if this account number starts with 9, let's say I have an account 91123. So this account must have at least 2500 US dollars. So this is a constraint. Sometimes we need such type of constraints for our records. So if we have not applied this constraint, then this table would not be in DKNF. Replace R by decomposition D, R1 and R2, where R1 is branch, account number and balance with the constraint that account number does not begin with 9, and R2 branch, account number, balance with the constraint that account number begins with 9 and the balance is greater than or equal to 2500. So what we do, we make two tables for this single table and apply this constraint on this table. So the first constraint would be if it has account number starting with 9, then apply this condition of balance that it would not be less than 2500, and in second table the account number must not start with 9 and the balance could be any amount. So this is the summary of normal forms. In first normal form, we check for multi-value attributes. If exist, then we remove the multi-value attributes by giving new rows in a table and identify the keys. And second normal form, we look for partial dependencies. If there is a composite key, then we check whether the attributes are dependent on the part of that composite key and eliminate such type of thing by decomposing that table into multiple tables. In third normal form, we check for transitive dependencies and eliminate transitive dependencies by creating new tables. In BCNF, we ensure that all the candidate keys are determinant. So for this purpose, we also decompose a single table into multiple tables. In fourth normal form, we look for multi-value dependencies and decompose a single table into multiple tables accordingly. In fifth normal form, we decompose a table into possible level, means this would be the end of decomposition. After that, the decomposition would be not possible, or we may lose some data while decomposing the tables. And the last DKNF is about the domain constraints. Actually, in this, we enforce the constraints on the database tables and their attributes. So this was all about normalization. Thank you.